Welcome to Sundar's lecture, and this is lecture number 7. And what are the topics we have seen in the last lecture? We have taken numerical problem, and we have solved the resistors connected in series and connected in parallel. And we have found that if resistors are connected in series, then effective resistance will be increased, and if resistors are connected in parallel, then effective resistance will be reduced. That is what we have seen. And we have taken a complicated problem between A and B. We have seen both parallel resistors and series resistors connected like this, and we have found what is the effective resistance between point A and point B. That is the final answer. We got it as 2.8304 ohms in the last problem, right? Now we will go for a new topic, that is the topic is voltage division rule, and it is applied only in the series connected resistor circuit anyhow. So this is the voltage source connected across the series resistor R1 and R2 like this. Now what is the current flow here? That is also I, right? So now you just try to write the KVL expression. Start from this point and come over here and come here. So what you will get? So V will be equal to IR1 plus IR2. You try to write the KVL expression, you will get this value, right? So from here, what I can do, I can get I constantly outside, so it becomes R1 plus R2, and that will be equal to V. So if I want to write what is I will be equal to V divided by R1 plus R2, right? Then what is the voltage between these 2 points? Between this resistor, you will get what? Voltage between this resistor, you will get, that is I am writing it as V1, and between these 2 points, these two points, it is V1, and these 2 points I am writing it as V2. And what is this value? The current in this resistor is I, and value of resistor is R1. What is voltage? Voltage is equal to I into R. What you will get here? I into R1, that is V1. And if you go for V2, then you see current is same, because this is series circuit, then current will flow, same current will flow in the R2. What you will get? This will be I into R2, which means I can write here anyhow, V1 will be equal to what? I into R1, right? Now what is I we have seen? You see I we have found it as like this, right? V divided by R1 plus R2. Just you substitute here. What you will get? V1 will be equal to V into R1 divided by R1 plus R2, right? So this is the final expression. And if you go for V2, you see V2 is equal to I into R2, right? What is I? V divided by R1 plus R2, and what is this value? This is nothing but R2, right? I have just substituted I value, that's all, right? Now you compare these two expressions. You see this expression V1, which is equal to, if you want to find what is V1, then total voltage into the resistance across that voltage, that is R1 divided by total resistance. And you see, I'm just generalizing the terms, that's all. Actually, what is current division rule? We will write a definition for that. And that definition, I'm just telling it in the formula, right? I will write down anyhow. See, this is the definition. Voltage drop across any resistors in a series circuit. That should be very clear. In a series circuit, it is applicable. Is equal to ratio of that resistor value to the total resistor multiplied by the total voltage. That is what we have seen here. You see, what is the voltage drop across this resistor? That means V1 will be equal to ratio of that resistor, that is R1, divided by, what is that? Total resistor R1 plus R2 multiplied by total voltage, that is nothing but source voltage, given voltage. That is what the formula for V1 we have found. As well as you go for V2, what is that? Here V2 will be equal to R2 divided by R1 plus R2 into V, right? So if you want to find what is the voltage drop across this resistor, then ratio of that resistor, that means R2, divided by to the total resistor R1 and R2 into what? Total voltage. That's all. So this is how you need to find a voltage drop across any resistors connected in series. This is generalized formula. You don't need to find current here, that's all. Even though if you apply KVL and you write down the expression, you will get what is V1 and V2. For to find what is V1 and V2, this is V1, this is actually V2. You need to find what is I. Then you need to simplify these two resistors, add those, and so many things will come. Anyhow, it is a simplified formula. This is nothing but current division rule. And we will see another important thing. This one we apply very rarely. We don't use current division rule often, but voltage division rule frequently, but current division rule we will use frequently. That I will explain now. And you see, we have taken a parallel circuit now. Current division rule will comes only applies in the parallel circuit, which means this two resistors are connected in parallel, and this is connected across a voltage source. Which means what? Voltage across R1 is what? Simple. Voltage across R1 will be what? It is V. See, because this one is connected to this point and this one is connected to this point. As well as what is the voltage across R2? That is also same. This is also V. There is no difference. There is no difference. Try to understand. And if you apply KCL at this point, now you try to apply. I will write. This is point A. And at point A, what we are going to do? At node A, anyhow. KCL at node A. What is the current coming? You put equal to symbol. You put equal to symbol. IT is coming in. That you have to put it in the left hand side. That is IT. And you see I1 is going away as well as I2 is going away. So what you need to do? I1 plus I2 you have to write. That's all. Right? Now you see voltage. If I want to write voltage, what is voltage between this R1 resistor? What is that? V, I can write it as, I will take a color anyway. So V will be equal to, you see, I can write I1 into R1 because what is the voltage between these 2 points? Which is nothing but I1 into R1, right? I1 into R1. I1 into R1. And you see what is the voltage across this R2 resistance? That is also V. So what I can write? That V is also equal to I2 into R2. Right? Now what you do? You keep this I1 one side and you bring R1 to other side. Like this. Thus, we have found equation number, let it be equation number 2 and let it be equation number 1. That's all. Right? Now what you do, you just substitute this expression number 2 in 1. Simple. What you will get now? So, IT will be equal to, I have to substitute instead of I1, I2 into R2 divided by what? R1 plus what? Plus what? This is I2. Right? This is how I will get the expression. And what I will do, you see I2 is here as well as here. So what I will do, I will take I2 commonly outside. If I take I2 commonly outside, then what I will get? R2 divided by R1 plus 1. And if you take LCM, what you will get? This will be equal to I2 into, this is R1 and this will be R2 plus R1. And that is nothing but IT. And what I need to find what is, and what I need to find what is I2 now. So if I want to find what is I2, I will write like this. This I2 will be equal to, you just bring this term to other side, so it will be inversed, right? What you will get? R1 divided by R1 plus R2 into IT. That means this is total current. That's all. And similarly, you get I2 in this expression and you just substitute in IT, you will get I1 will be equal to R1 divided by R1 plus R2 into IT. Sorry. This is actually wrong. What you will get, I1 will be equal to R2 divided by R1 plus R2 into IT. So this is how you will get for I1. You just simplify. I will write similarly. You just I have taken I1 R1 to other side, right? You just bring R2 to other side so that you will get I2. You substitute that I2 in this expression, you simplify, you will get I1 expression like this. Now, this I will generalize now. So you see, I have found what is I1 and I2 directly here, right? So I will generalize this term and I will write the definition. And you see, I have written the definition, which means current in any resistor, which means you take this this resistor current, that means I1. Current in any resistor in a parallel circuit, which means this is connected in parallel, is equal to ratio of opposite resistor, which means if I want to find what is I1, then what is that? You see, if I want to find what is I1, then opposite resistor R2 ratio of opposite resistor, that is R2 to the total resistor, you see, divided by total resistor R1 plus R2 multiplied by total current. What is this total current? IT. That's all. And if you see, you take I2. If I want to find what is I2, which means in this resistor current, then opposite resistor R1 divided by total resistor R1 plus R2 into total current. That will give you the current in R2 resistor. You see, this is applicable only in the series, parallel circuits. See, voltage division rule is applied only in the series circuit, and the current division rule is applied only in the parallel circuit. And this one we frequently use. We always use this current division rule wherever we go, because if you know what is current in this resistor, what is the total current? For example, if you know what this is 2 ampere, and if this is 1 ohms and this is 1 ohms resistor, then you can directly substitute here to get the current in each resistor. This topic is very interesting, right? We will apply this. You just gather the idea about what is current division rule, then we will apply. While applying, you will get deeper knowledge, right? Anyhow, we have seen both rules, right? Thank you. We will see in the next class.